This video shows how the buffer overflow attacks exploit source code and can take advantage from it. This is a view of the Real Bank online banking application. This is a view of the source code that implements the banking application. In this example, the allocated size for the username and password buffers are 15 characters. If these buffers can be overflowed, all out-of-boundary bytes may alter the value of the return address toward a higher address. If the return address is changed, the execution flow is hooked to the new address, if valid, and when the function returns, the code at that location will be executed. In this case, the code is authenticated equals 1. The function credential check compares the user input with the valid credential. Bob logs in using his username and password. Bob is authenticated, and the system allows Bob to view his account information. Now, a different user tries to access Bob's account. The system will ask the user to re-enter the credentials. One day, Marvin visits the website and tries to hack the application. He enters a long string as the user input and a random password. Without a valid credential, Marvin has successfully logged in to someone else's account. In another situation, instead of logging into someone else's account, Marvin can cause the system to crash. This can cause a denial of service for Real Bank. Now, how do we reverse engineer the buffer overflow attack? First, we look at the misuse case view of the online banking website. The view presents extensions and exceptions to the main success scenario, which are potential attack vectors. From this view, we can see what developers intended users to do and what hackers can actually do with the system. When accessing the online banking website, a regular user intends only to access his or her online banking to view his balance or make a transaction. However, a hacker has a different intention for using the website, which is indicated by these red lines. A hacker can enter a long string of characters. As a result, the banking system directly authenticates the hacker and gives him or her the access to the account without actually checking whether the credential exists in the system. Now we explore our process view. The view contains additional information about the flow of control during the interaction and can show specific locations within a sequence of method calls where the system can be exploited. In a case of a regular user accessing the website, program execution starts when a user accesses the URL of the online banking website. The program then calls realbank.cpp. That displays a console to the user. The system utilizes gets method to accept input from the user. This is the exact location where the vulnerability occurs. With the function gets, the ending new line character is not included. In addition, the function gets does not let you specify a limit on how many characters are to be read. When a hacker comes in, he or she can enter a string that has a bigger size than the size of the array used for the buffer. As a result, the hacker can somehow bypass the credential check, enter the system, and view someone else's account.